Okay, so today, lecture 4, we talk about partial derivatives of multivariate functions. Okay, so you are used to derivatives of univariate function. Today, we deal with multivariate function and the new concept, which is the concept of partial derivatives. So, if we have a function of two variables, f of x, y, we can define two partial derivatives, which are fx and fy. What does it mean? Fx means that you keep y fixed and you vary only x. What is fy? Fy means x kept fixed and only y varies. Okay? So fx evaluated at a point AB is the limit when h goes to 0. Y is fixed equal b, and x is varied, so close to a plus h minus f of a. So y is fixed and a vary, and we calculate this limit. Fy, the partial derivative with respect to the second variable y, here you see x is fixed and the second variable y varies. B plus h and b. This is what we call partial derivatives. It's a derivative with respect to one variable, keeping the other variables fixed. So if we have z, the output of a function f of two variables x and y, we can denote the partial derivative in several ways. We can denote it fx, xy, means that it's a partial derivative varying only the first component x. Or we use this notation, partial f over partial x. Okay? So fx, df dx, f1 means partial derivative with respect to first component, d1f, dxf, all these are different notation for the same quantity, which is the partial derivative with respect to x, the first component of this function f of several variables. With y, we can use the same idea. So we can use fy or dy of f or f2 or d2f or dyf. Okay, we can use any of these notation to represent the partial derivatives of a function. Good, let's see an example. So we are given a function here, fxy, a function of two variables. This is the expression of this function, easy function, polynomial. And we want to compute the partial derivative with respect to x at the point 2, 1, and the partial derivative with respect to y at the point 2, 1. So how can we deal with this? We start, what is fx of xy? Fx means we keep y fixed and only x varies. So y is a constant here. Y fixed, constant. Okay? Whereas x varies. This is a variable. So what is the derivative of x cubed with respect to x?
3x square.
3x squared. Bravo. Plus, what is the derivative of x squared y cube with respect to x?
2xy cubed.
Exactly. So y cube is a constant. We don't derive it. We derive only x square, and the derivative of x square is 2x. What is the derivative of minus 2y square with respect to
0.
x? So this, we have no x here, doesn't depend on x. So this is a constant with respect to x. So its derivative is 0. No x in this term. Okay? So this is the fx, the partial derivative with respect to the first variable. It's 3x squared plus 2x y cubed. He wants the value of this function at the point 2, 1. So how can we calculate fx to 1?
Direct substitution.
By direct substitution, we substitute x by 2 and y by
Y.
1. This is the value of
Yes.
x here, and this is the value of y here. And we obtain 60. Okay? Now this is the partial derivative of f with respect to x at the point 2, 1. If we want to do the same thing, but now we want to calculate fy.
X cubed will be 0 because there is no y.
Exactly. So here, no y. So this is constant with respect to y. Bravo. So 0.
X squared
X
by
square is a constant, and the derivative of y cube is
3y squared
3y squared. And here, minus 2
minus 4y.
times. Okay, so it's minus 2, and the derivative of y squared is 2y. So the result is 3x squared y squared minus 4y. So this is fy. This is the partial derivatives. Partial, لأنه we derive with respect to one variable only, not all variables at the same time. Okay, so it's called partial derivatives. And then it's easy. So just plug and direct substitution, substitute x by 2, y by 1 in this expression. And you will get the result. 4 times 1 equals 8. This is fy at 2, 1. So let's see an example. Given this function f of two variables, find fx11, find fy11, and interpret these numbers geometrically at the slope of some lines relatively to the given surface. So let's start by fx. So what is fx at a point xy? Again, y is constant, fixed. X varies. So what is the derivative of 4 with respect to x?
There is no x.
There is no x, so
Yeah.
0. What is the derivative of x minus x squared with respect to x? This is minus
2x.
2x. And the derivative of minus 2y squared with respect to x is 0. So here fx is minus 2x. fx evaluated at 1, 1 equals negative 2. What is the interpretation now of this value? This means that we have to calculate z, which is f of 1, 1. What is f of 1, 1? It's 4 minus 1 square minus 2 times 1 square. So here the output is 1 also. So this means that the point P1, x is 1, y is 1, Z is 1, is a point on the surface representing the function f, where we calculated the partial derivative. And so this is the graph, this is the surface S, this is the point 1, 1, 1, and this means that the plane y equals 1 constant intersects the surface z equals fxy in the parabola here c1 2 minus x squared obtained for y equals 1. Just replace, so c1, the equation of c1 is that just replace y by 1 in this formula. So it's 2 minus x squared, and this is the equation of the parabola. 2 minus x squared, y equal 1. And the slope of the line tangent to C1 is negative. The slope of the line tangent to C1 at this point is negative 2. Okay, so here, this is the interpretation. If we do the same thing with respect to y, so what will be Fy at xy? Fy will be 0 plus 0, and here we obtain minus 2 times 2y, so it's minus 4y. Fy at the point 1, 1, minus 4y, sorry, is negative 4. This is the value of the partial derivative Fy at 1, 1. Now, geometrically, so our surface S has equation Z equal 4 minus x squared minus 2y squared. When x equals 1 and y equals 1, we calculated Z to be 1. So the point P111 is on the surface. When x equals 1 fixed, we obtain the curve C2 with equation Z equals 4 minus 1 square minus 2y square, which means Z equals 3 minus 2y square, x fixed equals 1. And here, the slope, negative 4, this, the line with slope negative 4 is tangent to this curve at the point P111. So we can see it like this. This is line with slope negative 4 passing through the point P111, and it is tangent, means مماس تلمس the curve in one point اللي هو the point P11. Okay, so this is what happens graphically. Okay, this is the interpretation of the partial derivative graphically. So other examples, the function f, which is sine of x over 1 plus y, and we want to calculate dxf, or قلنا we can also use the round d. It's the same thing. It's another way to define the partial derivative with respect to x. So what is the derivative of this function? So I recall the chain rule. Should call the chain rule for a function of one variable. Here y is fixed, so we deal with function with of one variable اللي هي x should call the chain rule. So if we have g1 of g2 of x, the derivative of this function is the inner part g prime 2 times the outer part g prime 1 evaluated g2. So if we apply this formula, so the inner part is g2 of x. What is g2 prime here? X only vary, y is fixed. If we derive x over 1 plus y with respect to x, شو راح تعطينا guys?
x over 0 دائما ما في x في المقام.
X over 0, of course not. X over 0 is undefined. So here again, which type of function of x have you? Well, now y is constant. So you deal with this as you deal with x over 5 or with x over 3. What is the derivative of x over 5?
1 over 5.
It's 1 over 5. What is the derivative of x over 3?
1 over 3.
It's like 1 over 3 times x. So here is the same. It's like 1. This is the constant times x. So what is the derivative of the inner part with respect to x? With respect to x هنا نحطه. What do you obtain?
1 over 1 plus y.
1 over 1 plus y times the derivative of x is 1. So here هذه 1 over 1 plus 1. Now, what is the derivative of the outer part? So g1 of x is sine x. What is the derivative of sine x?
Cosine x.
It's cosine x. So finally, what is the partial derivative of f with respect to x? It will be g2 prime, so 1 over 1 plus y times g prime 1 اللي هي cosine evaluated at g2, so evaluated at x over 1 plus y.
دكتور.
Yes.
So we to avoid confusion, we separate the fraction so we can do it more easily, so that no confusion and mistakes.
How can we
Right.
separate? What do you mean?
Separate the fraction so that we can
How? Tell me.
x over 1 and y plus y over 1, or maybe something like that.
You cannot separate this because you have a sum in the denominator. So you can do nothing. The only thing here, the only good news is that only x varies. So here, the only thing is that you can write it as in this way, and this is a constant. Okay? So
Yeah,
it's a
that's what I mean.
function. So you write it in this way. Okay?
The same that you wrote in red,
Yes.
right?
Yes.
Same idea,
Yes.
concept.
So this
Yeah.
is a constant and dependent of x times x. So it's like 3x, it's like 5x, it's like 9x. You deal with it like this. dx f will be, using the chain rule, will be dx of the inner part, okay, times the derivative of sine, which is cosine, evaluated, and keeping the inner part the same. And this partial derivative, statini 1 over 1 plus 1 cosine x over 1 plus 1. Okay, when you compose, you derive the inner part times the derivative of the outer part evaluated at the inner part. Let's see dfy. dfy is a bit more complicated than dfx in this case. So what is d dy of f? قلنا here it's a sign of a fraction. So we use the chain rule. So we first derive the inner part with respect to y times the derivative of sine اللي هي cosine x1 plus 1. إذا اللي باقي لنا هنا it's a bit more complicated to calculate this derivative now. So what is the d dy of x over 1 plus y? Here again خلينا نجيبها هنا هذه. So here again we can write it as a product of two functions, x times 1 plus y. And since x is a constant ممكن نطلعها برا. And I need to calculate this derivative. 1 over 1 plus y. Okay? مين يتذكر what is the derivative of 1 over g of x prime? What is the derivative of the reciprocal function? The derivative of the reciprocal function is minus g prime over g squared. Okay, so you plug this for g of x equal 1 plus y. Okay, so this gives me x برا ما ننساه times g هنا g of y of course. What is the derivative of 1 plus y with respect to y? So times minus. What is the derivative of 1 plus y with respect to y? هذه easy كل تعرفوها.
1
It's 1 over g squared, so 1 plus y all square. Finally, it's minus x over 1 plus y squared. So finally, here the final result is minus x over 1 plus y all squared cosine x over 1 plus. So this is another example, and this example is different from the previous one because here we have still a function z of two variables x and y, but the problem is that we have not an explicit expression for z. So z is related to x and y, and we haven't, like in a previous example, an explicit function. F is sine x over 1 plus y, well, it's a log or exponential. So here, z is a function of x and y. Z is the dependent variable. X, y are the independent variables. The independent variables. But here you see we have z cube, we have z. So we cannot find, it's an equation of degree 3 in z in terms of x and y. And we cannot express z in an explicit way to in terms of x and y. This is why here we say that z is defined implicitly, not explicitly. No explicit expression. Okay, no explicit expression of z in terms of f. And He's asking to calculate the partial derivative of z with respect to x and with respect to y. So try to focus. We can deal also with such cases in this way. So let's start by the partial derivative with respect to x. Recall just that z depend on x and y. Okay, z is a function of x and a function of y. So when x varies, z varies. Okay, so here dz with respect to x, here only y is fixed. Okay, x varies and z as a function of x also varies. So how to obtain dz with respect to x? The idea is to derive this equation with respect to x. d dx of each of these terms. So x cube plus d dx of y cube plus d dx of z cube plus d dx of 6xyz equals d dx of 1. So we derive the whole equation. This is the first step. Then the second step, we calculate each term. So what is d dx of x cube?
3 x2
3x squared, correct. Plus, what is the derivative with respect to x of y cube?
0.
It's 0, bravo, because y is constant with respect to x. Plus, and this is the novelty. What is the derivative with respect to x of z cube?
0.
No, it's not 0 because
No.
z varies. Z is a function of x. Okay, so here we consider it as a function of x. How to derive f cube of x? What is the formula seen in calculus for the derivative of the cube function, f cube of x? This is a chain rule, static n, the power 3 times the inner function here, f prime times f to the power 3 minus 2, so f square of x. Okay, this is the formula for a function of one variable. We can use it here. So we get 3 is a constant. Here we have f prime. Here we don't use f prime since it's a function of two variables. What do we use? We use the partial derivative dz dx. Okay, so dz dx, we replace f prime in this formula. Okay, here we have a function of two variables. We don't use f prime anymore. We use partial derivatives times f square اللي هي z square. لسه عنا هذا plus d dx of 6xyz. So this is the derivative of a product. The derivative of a product, f times g, f of x times g of x, prime, هي f prime x times g, plus f times g prime. ليش نحكي على derivative of the product? Because here I have a product, and this product I have two function of x. I have x, which is a function of x, and I have z, which is a function of x. Here, the derivative of the product is the derivative of the first function here, x times 6yz, plus the derivative of the second function اللي هي z, then 6xy, the derivative of z with respect to x. And then هذه its derivative, we have the product of two function of x, so we use the derivative of the product. So we simplify this expression. We didn't وصلنا هنا بعد equals. What is the derivative of 1 with respect to x?
0.
It's 0 because we have no x. It's constant with respect to x. Okay? So we derive this equation. We obtained a new equation. If I simplify it, so the third step, I simplify this new equation and I try to isolate if possible dz dx اللي هي نبحث عليها هنا the unknown dz dx. 3x squared plus 3 dz dx times z squared plus what is the derivative of x with respect to x?
1.
It's 1, bravo, times 6yz, so 6yz plus 6xy dz dx. هذه نتركها لأنه ما نقدر نحسبها. We don't know z explicitly and second term is z. يعني شو صار عندي؟ صار عندي equation with the unknown dz dx. Okay, so I solve this linear equation. Just I move terms which are not ما فيهم dz dx نوديهم للطرف الثاني ونخلي اللي فيهم dz dx to the left ونطلعها as a common factor. dz dx وين موجودة؟ موجودة هنا شو يبقى 3z square وموجودة هنا شو يبقى 6xy equals والباقي كله أوديهم the other side تعطيني minus 3x square minus 6yz and I'm done خلاص. The final result is dz dx equals هذا minus 3x square minus 6yz وهنا كان product يصير division over 3z square plus 6xy and this is the expression with respect to the partial derivative of z with respect to x when we don't know explicitly the expression of z. So this expression depends on x, on y, and on z also. Let's do dz dy. Let's do dy z. Same idea. Step 1. Derive all the equation with respect to y. So dy x cube plus dy y cube plus dy z cube plus dy 6xyz equals dy of 1. Here dy means x is fixed. Y and Z varies in terms of 1. So what is dy x cube?
0.
This is 0. What is dy y cube?
3 2 square y square.
3y square, bravo. What is dy z cube?
3 derivative of z to z power of
dz dy times z square. So this is, you see the difference between the derivative of y cube هنا عندنا directly the variable to the power 3. هنا عندنا a function of the variable to the power 3. Okay, this is the difference. The derivative of f cube of x هي 3 f prime f square. Okay, so this is what I'm using here. Plus dy of this, so 6x is constant. شعلنا dy of y times z plus 6xy dy of z, or dz dy. They keep the same notation حتى ما تطلع. Equals dy1 here 0. So this is the step 2. Step 3. y هنا 0 راح. 3y square. 3z square dz dy. 6x. What is dy of y قلنا؟
يصير 1.
1. So z plus 6xy dz dy equals 0. خلاص نشوف التيرمز اللي فيهم dz dy اللي هي my unknown. خرجها common factor. منين تجي dz dy؟ تجي من هنا. ايش يبقى؟ 3z square. وجي من هنا. ايش يبقى؟ plus 6xy. والباقي كله نوديه للأذر سايد اللي هم هذا وهذا. دي ما فيهم دي زد دي 1. عندي 4 terms 1 2 3 4 and I'm done. Finally the final result is that dz dy will be minus 3y square minus 6xz over 3z square plus 6xy. So this is how to deal when we have an implicit relation between the different variables. We cannot express explicitly z in terms of x and y. They are related through an equation relating them, which we cannot isolate z to have the function explicitly. So we use this strategy to calculate the partial derivative of z. Of course, these are easy cases where you can deal with that.
دكتور,
Yes.
can you explain step 2? I tried to understand. Step 2, the last part of
هذه.
6xyz, yes.
So how did we obtain this? This is dy of this term, 6xyz. شعلنا in this term. عنا product, صح?
صح.
In this product, this is a constant and this is a constant. ممكن يطلعوا برا. متفقين؟
متفقين.
هذه not constant, هذه not constant because y and z both varies with respect to y. Z is a function of y. This is all what I know. Okay? Then it's not a constant, ما تطلع برا. إذا عندنا هنا the derivative of a product of two functions of y. How to calculate the derivative of a product of two functions of y? القانون شو يقول لي؟ f prime y times g, you derive the first, keep the second fixed, plus you keep the first and you derive the second. هذا قانون the derivative of the product. زين؟ وهذا هو اللي طبقته. إذا 6x هذه برا، أفتح براكت تعطيني DYY times Z. Derive the first plus I keep the first DYZ.
تمام.
اوكي، هذه ايش تعطيني؟ تعطيني 6x times هذه 1 times Z
Z and
وهذه تعطيني y
Y.
وهذه اللي كتبتها دي زد دي واي ولا دي واي زد بس هذا. اوكي، بعدين I distribute I obtain.
اوكي.
وضحت من جهة هذه؟
ايه
It's
وضح.
the derivative of the product. Give me sum of two terms.
تمام.
So this is the basics of partial derivatives. This is for two variables. What we have said for two variables is valid for any number of variables. So if we have more variables, for example, here we have a function of three variables, x, y, z. It's exponential x times y, ln z. So here we can define fx, fy, and fz. Partial derivative with respect to the first variable x, to the second variable y, or to the third variable z. Let's start. So here, خلينا نشوف fz for example. Or dz of f. Here, x, y fixed, and only z varies. Okay, so it's different from the previous example. هنا z is a function of x and y. Z is the output. هنا لا. We have three inputs. The output is another variable t ولا ما ادري شو اسمه. Okay, واضح الفرق بين example 5 and example 4? Example 4 is z is a function of x and y. Okay, no, here x, y, and z are independent variables. We have a fourth dependent variable t, which is the result. Okay, so keeping x and y fixed, z varies. شو رأيكم في هذا exy هنا in terms of z؟
ديريفيتيف بصير اي اكس واي المفروض.
إذا هذا constant ما فيه، مع البرودكت يبقى exy، هذا ما يتغير times dz of ln z. What is the derivative of ln z in terms of z?
1 على زد.
1 over z. So this is the partial derivative with respect to z. Now what is fx?
So it will be y
So
and z
for
fixed.
fx, y and z will be fixed, yes.
Okay.
You know, y, z fixed. So here, in this product, ln of z is constant. ما فيها عكس، لأن هذه تبقى.
Yes.
And we derive this term, dx of exy. What is the derivative of exy with respect to x? هذه again, chain rule, the exponential of a function of x prime واللي هي f prime exponential f of x. زي اللي جاتكم في الكويز exponential 2x prime هي 2x prime times exponential 2x، يعني هي 2 exponential 2x. إذا هنا شو راح تعطينا؟ تعطينا ln z dx of xy exponential dxy. تعطينا ln z. What is the derivative with respect to x to xy?
XY.
لا،
y it will be
تعطيني y is constant تخرج مش مشكل، ممكن نحلها خطوة خطوة حتى ما أخطأ. and then ln z y and dx of x
It will
كم؟
be 1.
زيرو يعني 1
1. Derivative of x is 1. EXY. And this is the result. Okay? Y EXY ln z. What is FYX? FYF?
should be the same بس X.
هذه it will be the same because x and y are playing symmetric roles. Okay? So here, no need, if you understand, well, no need to do all calculation. Just when عندك y, you replace it by x and x by y. المفروض this is f1. Okay? It's not exactly the same, but they are playing symmetric roles. كأنك x هي صارت y و y صارت x. They are playing symmetric roles.